Okay, so today we'll talk about the Presto C++, the next decade in SQL processing. I'm Amit. I'm working as a software engineer at Meta. Okay. So the main topics we are going to cover, only few topics: the introduction, the Meta warehouse, how big and how large it is, some historical context about Presto, and mainly how we have built Presto C++ worker and enter Presto with new velox, and how we are running it, and where we are, and what are the next items that we have in mind. So Meta warehouse is one of the largest data warehouse in the world. We have Presto, Spark, Sapphire, which is Presto and Spark running together, different kind of storage engines, metadata storage, permission service, type resolution service, many file formats, and very large scale distributed storage systems to query. And Presto serves almost millions of query per day among all these systems. So some brief historical context. At Meta, then Facebook, the Presto 2015 to 2017, after its starting Presto, it was doing the Hive migration and mainly used for external analytics. Sorry. Okay, we get here. And in 2018 to 2019, we are mainly worked on interactive and batch. The project was donated to Linux Foundation. And 2020, 2021, major highlights was doing elastic compute, caching infrastructure. And beyond 2022, we started looking in efficiency, native execution, and very fast latency sensitive workload. So historically, the Presto ran as a coordinator worker model. So we have one cluster with one coordinator and many workers. We also have multi-coordinators, but the multi-coordinator is phasing out at this point. We have many clusters, and Presto is available globally for all engineers and data scientists that work in Meta. We have a layer of routing Presto gateway that allows us to intelligently send traffic to Presto clusters, do load balancing, and do many tricks that allows us to kind of efficiently navigate the traffic. And everything is in Java. From gateway to coordinator to worker, everything is written in Java. It's in open source, built with Maven and everything. And we used to have a major operational cost because of how Meta infra is laid out, because 95% of Meta infrastructure is in C++. And Presto being on Java stack does not play well with what we had to operate on. At the same time, Presto is a very mature product. It has decade worth of usage, decade worth of expectations. Even something like if you have a incorrect result, if it's consistent, it becomes the standard in the company to keep running with those kind of incorrect results, because as long as it's consistent, it's treated as correct. And we have faced over the years in last decade many problems to run JVM at scale. For a few machines, for small workload, JVM might be okay, but for running thousands of machines in parallel, doing very high performance computing, we continuously faced problems with garbage collection and JVM pause and so on. So journey to Presto C++, why? So definitely, it was time to modernize Presto. It became dated, and we want to make it a new Presto with powered by Velox. And the first feature we keep in mind among everything else, it needs to be fast, and it needs to be reliable for us to maintain at many machines, probably for the next few decades. And the cost of running it needs to be very low, and we should be able to service it, triage it, or fix it quickly with the new infra. And of course, whenever we do this kind of migration for a 10 years old system, it's a very complex procedure. But we need to make a migration that is really fast, that could migrate things in place, no extra capacity, and find a way to ensure that the migration does not break our existing customers, which there is a huge usage of Presto. People are using it for reporting, for all sorts of usage at Meta. And at the same time, we need to keep the architecture very simple, because at scale, only the simple things can survive. And for next decades to come, we need to open new opportunities with Presto. For that, some of these we'll touch today. And another most important thing is very tight integration with Meta infrastructure, which going to C++ give us all benefits that Meta infrastructure gives for all of its services. For example, code landing, release, verification, debugging, triaging, code dump, anything that we get from the infra, we want to use it in Presto, and we do not want to do anything custom. Okay, so we have been giving talks about Prestissimo for Presto C++ for some time. So from last PrestoCon, this was the status. It was around last November, and we were running some of the low priority batch queries, which and some of the pre-verified high priority queries. And we did not have any general release for this product, because we had to verify the query before to run them. Verify means verify for correctness if it's matching with Java stack. And we did not have any interactive deployment. We did not have global availability. And we had a lot of routing imbalance. Like, how do we know on fly if the query can run in C++, in Velox, or in the traditional infra? This is very important for us because we are doing an in-place migration, so we need to have a very good way to control this routing. So at this point, the state of the union where we are. So we are able to make Presto C++ general available, and any query, we can say that if the query has a valid Velox plan, it can run in Presto C++ with correct result. The result might not match for between Java and C++ stack, that we'll touch a little bit, but the result will be correct. We have migrated almost 70% of our batch traffic and roughly 20% of our interactive traffic. And we have deleted the large batch mode, which was a traditional way to scale large pipelines to write in intermediate tables. We were able to delete that entire stack of queries and the code and we could run them in Presto C++ without anything additional added in the engine. We have also started taking more aggressive goals, like killing another infra, Presto on Spark, which is internally called Sapphire, which we have migrated 30% of the workload in Prestissimo. And this is due to Velox that we haven't even added any capacity to do these migrations. These give us enough bandwidth to run more queries because of the Presto C++ deployment, and all that work have been done in Velox. We have been able to migrate many company critical use cases in Presto C++ that was otherwise could not be run in Presto Java or even any other stack. And we have also been able to define what is the pricing capacity model in terms of dollar value. Kind of, in general, it's 50% less expensive in terms of dollar if you want to run the query in this new platform. Okay, so generally we have 2 to 4 times performance improvement. In extreme cases, it can be 20x better CPU and memory performance. We have reached a position where the engine can return correct result or fail with unsupported error. But at the same time, since it's taking workload from different engines, we have also started seeing out-of-memory problems, but still under manageable, but something we are working very hard to keep it under control. So at this point, we have seen like 20 in every region, the out-of-memory problem that can cause the server to die. It is still very resilient. The ohm numbers are lower than Java and very high success rate. And our North Star here is to run the queries slow if in memory pressure with spilling, but be able to handle gracefully the container ohms. And we also have seen, we are seeing almost 10 sec faults, even though that is rare considering the scale that we are running, but we are aggressively tracking it down and we have to make it almost 0. For Presto and Spark Stack, we have migrated almost 40% queries by count, 20% by capacity to Presto C++. We have been doing and will continue to do the memory management hardening in Velox to make sure we really account for usable memory and use all sorts of techniques to make to not go out of memory. And Presto and Spark, a traditional Spark workload, they run like an hour or 2 hours, but in Prestissimo, they are really fast. They are almost 7 to 10 times runtime improvements because of just how Presto works and how efficient we have made Velox. So we are making a new term that we are calling in the company is fast batch, which is even in the batch world, if the query takes few minutes to hours, we'll be able to run in Presto. So for general availability, verification is a very important topic, which I think is a very big topic. So we'll try to touch quite a bit on this verification area. How we make Velox to run in such a wide scale of queries without correctness issue or with minimum correctness issue, and when do we decide what. So for general availability, we know the performance that we always talk about 2 times, 3 times, 4 times, 20 times for price, that is excellent. But for us, it's not a few queries. We need to run warehouse worth of queries. And we need to do migration. We need to make sure the new queries are not only fast, they are also correct. So we need to have a fast car, but also we need seat belts. So the strategy that we took, and the strategies are evolving day by day, month by month, due to how the workloads we are trying to release. At the very beginning, like beginning of 2024, we had some sort of pre-verified queries. So for each Prestissimo release, Presto C++ release, we used to verify the queries beforehand. And verify means we used to say that, okay, if this set of queries, maybe we have, say, 100 queries, maybe 2 of the queries can match with Java stack, so we can release them for this particular build. Definitely, this process is good to start, but this will not scale and will not have enough capacity to verify everything. It's way too many. We'll need to double the warehouse to do that. At that point, we moved into loosely pre-verified queries. So that means once we verify something, it stays verified, given that we do not introduce any regression in Velox stack. And we'll talk about how we did that. And this also somewhat scale, but still expensive to maintain, because we need to keep a kind of database for what are the verified queries. And there are many shapes, sizes, sources. It does not work for all of them. But what we wanted to go is to some kind of blocking list. So for example, can we in Velox identify these functions, these tables, these text, or this combination of items are not correct and everything else is good. So because that way we could block some functions, and we could, not just functions, many things, but we could generally run all other queries and don't need to maintain a baggage of verified queries. But this is a very high risk job, because at that point we are practically allowing anything to run, and that needs to be correct, not just performant, it needs to be correct. So in the verification spectrum, so the main problem here is we have millions of queries, many query shapes. There is deterministic query, there is non-deterministic queries. And Presto is built, as I keep saying, decade worth of fixes, and Velox is just built from scratch. We just started working on 2-3 years. It doesn't have that industry experience. There are many differences between Java stack and C++ stack in terms of behavior. The library is different, the eval is different, floating point, regular expression, JSON, string conversion, you name it, there are differences. And Velox is, when Presto C++ stack is under very active development. There are a lot of change internal, there are a lot of change from outside to continuously add new stuff. So among all these, we need to have a fast verification procedure so that we could verify very quickly, and we also need to do every day with almost 1 day worth of changes. So we keep looking for solutions. So there are many items we did, but few of them we'll talk today. We wanted to look for cheaper verification, and we had this idea in Velox to do further. We have invested on that. We have expanded further to make custom input generators, make it compare with Presto eval. And this is our ground layer of testing, which makes sure that the components are good. They're very good to tackle overflow, underflow. If Presto Java side returns exception, in this side returns null, nan, infinity, all sorts of corner case boundaries are kind of flushed out with this layer. And the next layer, we do this classic Presto verification. But the verification requires a golden version and a new version. And then we need 2 sets of clusters. That will not work either, because we need to have capacity. So we started changing the verifier in many ways. We started reusing the production tables in the shadow runs, so that if a query that we want to verify already ran in production, we do not run it again. We just use their output and run in the new side, and we could verify 10x more queries. This made our verification very fast, and we also added a lot of change in verifier, like validating string as double so that we can do the checksums deterministically. We have made many rewrites so that the non-deterministic query becomes a deterministic query, and then we can do the checksum and verify. We also had, over the years, we have built many query banks. This is something we use to release Presto. So we also made sure that these query banks, these pre-verified query banks over synthetic data that works with Presto Java need to work in Presto C++. So this was another layer of stem that, okay, this stack is getting ready. But even after all these, we could make 50% traffic, say, deterministic, but there is half of them are non-deterministic, and there are many ways non-determinism can come in. And we need to find a way to continue verification. So we continuously fixed Velox and Presto Java so that they keep matching together. And we also are very fast to decide what we can tolerate in terms of mismatch, because not all matches can be handled. And we have improved the triaging process so that our verifier can itself do triage, telling us, okay, this one has a mismatch, but this is due to this kind of reason. And then even after all this, we have manual triaging for a few months to kind of, as Presto and Velox team tries together to ensure that the stack is getting ready. And whenever we verify, the verification results give us a very strong insight which functions or which part of Velox we can release without risk, and which part we still don't know, which part is under development, which part needs work. So we kind of connected this result with our routing infrastructure so that we could only send the pre-verified kind of allow list functions to the Prestissimo cluster. At the same time, this cluster needs to take a significant chunk of traffic. Remember, we do not have any extra capacity to run this. So we try to make sure not to have a very wide list that include almost all the functions that Presto offer. So we connected the routing with verification result. We have integrated API v2 and Velox plan checker with some handwritten rules to dynamically find if the query on the runtime, if the query can run in Velox stack or cannot run in Velox stack. So the query that we can run in Velox stack are become native eligible that can bounce back and forth between both systems. But there, for performance reasons, there are a lot of queries that we had to pin to the C++ stack so that they get guaranteed performance. The verification and routing, so basically the native eligible, after all these things, we have three sets of functions. The eligible ones can run in both infra. The native only can run in Presto C++ side, and the Java only means some of the queries that cannot run or have correctness problem, or customer has expectation on the old result, they need time to migrate. We can park them in Java. And we also have configuration to influence this plan validation, so that on the fly we could say enable functions, enable some source, enable or disable something to help us to release the product. So for some of the major non-deterministic sources of verification, we'll highlight here, but there are many. There is this lower upper that has the Unicode difference, because the JDK we run with JDK 8 inside Meta that has Unicode 6.2, and in Velox runs, and Velox and all other Meta infrastructure runs with Unicode 11 plus. So there is a lot of character mismatches. Regular expression, which is we use RE2, which is a very fast regular expression library, but it also has quite a few differences with Ioni, which is forked in 2019 in Presto Java's repo, and there are syntaxes that are not supported in RE2, and there are many cases there are result mismatch also. And there is the JSON functions, like SIMD JSON versus Java side, we have JSONs. They have the path difference. There are supported paths so that the results match, but there are many. There are a few unsupported paths, like when we put expression in the path. This syntax we don't have in Velox, and we probably likely will not add also. And we have to ensure that our huge customer base can operate on this moving infra. So we had very intelligent retry mechanism, some of them in place without failing the job, some of them failing the job and trying in Java, to keep the existing customer expectation and service level agreement that we have set up, which is in a moving infra like this, is very, very tricky to maintain. And even outside of this, there are way too many corner cases between these two infra, but we try to make sure the results stays consistent and pin traffic here and there to kind of achieve the consistency, and don't try to fix or overfit something in Velox that we feel is not a right decision. And this is a great learning experience of how the database eval works. doing it in this granular level and getting the opportunities is something I'm really thankful of, because we often work in the higher layer of systems, but releasing Velox to so many customers, so many users is something, some experience. So this is the status of batch queries. The top line, the pink line, is the query that we are eligible to run. And the blue line is the queries we are running. So we almost crossed the 75% mark in our batch world. And in the interactive side, we just started the migration this year. Interactive is giving us way more challenges, even after all these fixes in batch, and we are almost around 20% in that journey. So the native only, so at the same time, it is visible to customers, and we know this is the new stack. There are a lot of ways customers can opt in to run only in C++, and that's what a lot of customer wants. And at the same time, we in Java stack does not have many evolving requirements. For example, we have this experimentation platform use case that we are running in completely native platform. We recently been successfully able to run ads delivery experimentation platform in our generalized Presto C++ offerings, and which would have not been possible to run with the timeline and SLO they have without Presto C++ and Velox's work. And during this in this kind of work, it's not only just running some query. We have to deep dive in Presto and Velox stack, see where some inefficiency can happen. And we fix many things, like in this case, one example of the row-wise encoding for very wide tables, which these ads platform are using. But one of the important part of making Presto C++ and Velox to run is we have so many changes and so many fixes, so many new features, connectors, and we have to ship it very quickly with a confidence. If we ship once in a month or once in even every 2 weeks, we'll fall behind. Regardless of how many systems we are releasing, we need to release quick. So we have decided to release every week, and we have made the verification faster, and we have made all the knobs to turn on and off something in the fly to influence the routing. And so far, we have only found 2 major correctness issues that we could not catch before, and these are very tricky cases. One of them was merging the HLL data structure between Velox and Java stack. These are not really correctness, but compatibility, because in Velox, we used to use XXS hash, and in Java, we have murmur hash for approximate data structure. So Presto allows you to persist the HLL in disk. So if we hash with one and read with another one, it does not. It has a wide error margin. And we also fix the row container extract values with nulls. That is a issue it found during some kind of window spilling. And there are many contributions. I keep poking around in OSS to ask help us to fix bugs that we find, like one of them, like TPC data generation, not a bug, but it didn't match with what we had in Java. UID var binary casting, and there are more fixes that we got. We are thankful of that we got in Velox from outside. And we also ensured that we continue the general utilization across the clusters, so that we just don't run any few queries. We run 70–80%, which is the majority of the infra running in Presto C++, making it the new standard for the next decade. So the infra today, we have only 30% of hardware for Java and everything else in C++. We have a heavy routing logic that we have discussed a little bit, and we also see occasional slowness in runtime when the server is under heavy use. We have some sort of unsupported features in Velox stack that we continuously improve, like the Lambda support for variable arguments. We have the system, since it's running both of the infra, it getting a little bit complicated for our customers to add new functions, because now they need to add in Java, need to add in C++. The pricing model in a heterogeneous infra is hard to define. So, and the migration completion speed is something we are actively monitoring. We're trying to complete it very quickly. So the pricing model today, I'll go quickly. Customers can buy units to run queries, and the unit is usually the maximum of the total CPU time and total cumulative memory. And we have a way to convert these to units, and these units a customer can buy, and they can run that many units of query. At the same time, to ensure that Presto C++ is efficient, we need to make sure this unit cost for customer going down, which will then influence us, the system or the capacity management, to reduce the machineries, and which will reduce the hardware footprint. So the whole cycle needs to work for us to demonstrate that it is actually 50% cheaper. So we are on track to demonstrate this. And this is where Velox's power comes from. The economy of scale, when we could run many, many things cheaper, is worth. If it's a few queries, few machines, it's probably not that worth taking all this. So what is next? So the immediate next for us is to ensure the complete deprecation is done, because it is very tricky to maintain both infra. We have to release, verify. There is a problem with running queries in one stack, not running with another stack. And then where we want to go, we want to run milliseconds to hour-long queries in the same Presto C++ deployment, making it ultra fast. We want to expose analytics for machine learning training tables, which are wide, both for interactive and batch. We want to make the machine learning pipelines faster, maybe hourly. We call it fast batch. We have different file formats that have been released through Prestissimo, Presto C++, and Velox integration, like Nimble format, Metallic. We want to support larger maps, wide tables, feature reordering, and we have a few siloed deployment for customers that we also could not merge in our general offering due to performance problems. But now, due to Presto C++ and Velox, we could do that. So that's probably will go for next year. Okay, any questions? Yeah.
So we had actually a major problem with the result mismatch, and the question was that whose fault it is. So what did you do regarding that? It is C++ versus Java. Whose fault is it?
So, for example, I gave one example at the beginning. Like this one. So,
That's all right.
Can I go back? So it's not anyone's fault. We try to find which one is correct, and then try to match both. Let me go back. Okay, this one. So basically, in this case, we found problem in Java stack where it was not tackling the some escape character in regular expression parsing.
But you don't know what the result of the query is. So you give it to this guy, that guy. We tested a lot of that, by the way, at IBM.
Yeah.
So what we did was that we brought in another database. We brought in our DB2 and loaded the exact the same. We used a lot of TPCDS. And then we started correcting the
But TPCDS is few queries, right?
Huh?
There's like only few queries.
The results. And
yeah.
we also wrote our own queries.
Yeah.
Remember? So the thing was that we voted. Most of the cases, actually, we fixed velox and then
Yeah.
we won with velox, most of the cases, because we were not fixing the Java part. So
Yeah.
velox at the end was very good.
Yeah, yeah.
Whereas Java is amazing that what wrong results we're creating comparing with our DB2 product.
Yeah.
It was amazing. You know, it would no complain and just give me bullshit results.
Yeah, that is true, like the Unicode and stuff. But the important part for us was we have a existing customer base. So if suddenly we change result for them and it bounce back and
They
forth,
don't know. The data changes, the queries change. They don't know.
so that
You know,
we can talk about. But
these are big systems. They don't know.
okay. Any other questions? Oh, yeah.
Yes, hi. Thanks. My question is a little bit, I would say, out of the box, because I listened to multiple presentations, and everybody's talking about a code. So if we talk at Presto, what is the impact of poor data quality on all the query execution speed? It's like it's an elephant in the room, and it looks like we're totally ignoring that. I wondered if you can comment on that.
So, sorry, I didn't get. Is the
My question is, when you look at Presto query and how execution speed, performance is impacted by the actual data that is being queried. If the data is garbage, you can optimize till tomorrow. You're still gonna get slow execution speed or bad execution. So my question is, why data is not mentioned anywhere in this presentation or any other presentation when I'm talking about data quality?
So you are saying that, if I understand correctly, the table formats and partitions, these are not well written, or?
If something's wrong in the data, and you optimize the query.
Oh, so what we do, we have, so this is not in open source, but internally, we have a way to tell our customers that this table, this code is taking time because of this kind of reasons. So we surface some of these things about the data quality to the customers. We have something called, I don't know if Dr. Presto, this thing is not outside, but we have some insights on the tables. Even there is another data quality thing that if you look at like a ultra fast latency, say 2 seconds, 3 seconds, even millisecond, if you have some very small files, it is a problem. So we have been working on compacting it. A lot of storage-related optimizations is also going on. But for Presto side, generally, all the talks are on compute. So they try to not look in data, but again, you are right. If the data is poorly formatted, doesn't matter what you optimize.